We are back. This is the start of episode 4. On the last video, we covered connecting the servo motors from outside and bringing them in, and terminating the encoders and the positive and negative 24 volts to the motor. We also had brought the wire down for the limit switches. I wanted to go over that a little bit and just touch base. This is the breakout board that I had mentioned. I had some terminal pins, so I brought them in. The red leads in here supply the 24 volts out to the limit switches, and then the black lead goes to the pin that's correlated to in here. So basically it was like pin 2 for the Z-axis, pin 3 for the Y-axis, and pin 4 for the X-axis. And when you look at that, according to the C25, I had noted those down. So that's 11, 12, and 13, and that's for the limits to go there. So basically all we have to do is run our Ethernet cable from here to here. So there's going to be a lot of slack because I haven't yet to be able to find that short of a Ethernet cable. Anyways, in the interim, I started to somewhat connect the 120 volts, and that was simply from the wire, the wall plug coming in. And here's my terminal block. I have the common from the wall just comes down and goes directly to here, and then out of here and goes out to, I have a pole here that my interface, console interface, basically the monitor, touchscreen monitor, the push button, and the emergency disconnect, which is also the power enable to power the whole machine. So those wires come out here. The hot lead comes back from the emergency disconnect to this terminal block here to provide my 120 volts to this set of terminals. So from here I'll be able to power all the 120 volt items, the 24 volt motors power supply, these two power supplies, the solenoids, the computer, and the monitor. Actually, I take that back. The computer and the monitor I'm just going to tie in at the emergency disconnect inside the actual console, because they're little tiny wall wart style power connectors. So I'll just connect them from inside that box that's out there. I have to machine the G10 panels that go for that. I have a large format 3D printer, so I basically created a sandwich system. It has the two outer G10 panels with a 3D printed inner hollow insert, so I'll be able to bolt all the panels together and have the spot for the monitor. So interim, we're going to complete the 120 volt wiring to all of the components that is not switched by a relay at this point. So basically you're going to be hooking up a lot of commons on here. So I'll get those started, and then we will touch base after I get done, and we'll basically go over everything. Most of the 120 volt lines are ran, unless I think of something that I missed. I went through my check sheet. I think I have everything. The lines are ran, but most of it is not connected. So we'll kind of break this down a little bit. My first start in this was on the electric solenoids. These are AC solenoids, and they drive the ATC and the power drawbar. So I went ahead and rewired these all up. New connectors, new wire. The grounds are wired in parallel, and this is the chassis ground. The chassis ground is wired in parallel, and then it goes up and ties in to the actual chassis itself. The neutral is all in parallel, so basically I'm neutral sharing, but I'm all on the same neutral for the incoming line. So all the neutrals are in parallel, come up, and they go into the terminal block. or bus bar, however you want to look at it. And then all of the load or the common wire come up, and then they come out here, getting ready to be tied into the M26 expansion board. I have them all labeled for drawbar, you know, tool 1, 2, 3, 4, etc. So I have to run a hot lead from the terminal block, and I will also wire that in series, or not series, parallel to all of those switches. The solenoids draw very, very low current, less than a half an amp, it's like 400 milliamps. They're not very much. So anyways, the solenoids will be wired into this. I just haven't done that yet. I wanted to do a separate video of wiring these main components separately. So at this point, we're just focusing on AC and DC voltages and how they're going to get terminated. I ended up swapping. I had the smaller DIN rail terminal blocks up here. I didn't need that many, so I ended up putting the older style on there, and I felt the older style they were a little heavier duty. So I went ahead and put them on there. The only difference is that the jumpers were already pre-cut, so I had to kind of make them work in order to get turn these into just basically bus bars. So we'll break it down how we have it. We have our power, 110 volt comes in, goes into the first breaker, which is a 15 amp breaker. It goes from there and goes out to the console or the interface that you see and are going to be using. And then I have an emergency disconnect on our E off, and it also has a power button. So I'll be able to turn the power on, then the power will come back and goes right to the bus bar here, or this terminal block. And then this power is dispersed out through a single 12 gauge wire. Both of these are 12 gauge wire. It comes out with a single 12 gauge wire, comes back up, and then puts all of these breakers in parallel. So they're all tied to that single wire coming back to here. All the neutrals, the neutral comes in from the wall, it comes into here, and it also splits and goes to the console, because the monitor, power supply, and I'm still not sure yet if my cord is long enough. I haven't checked it yet. If the cord is long enough, then I'll put the power supply up there. If not, then the computer power supply will most likely be in here, and I'll have to wire in onto the bus bar assembly to power the little PC. None of the DC voltages are done. We're going to do another video on doing the DC voltages, so stay tuned for that. I went ahead and connected the little giant coolant pump, which has a current draw of like 1.7 amps, so it's really low. But I went ahead and terminated it into this external relay assembly, so it's already wired. The chassis ground is going to a connection point off the corner here, and then comes back through on the back side and ties into the normally open position, with my hot lead coming up and going into, or excuse me, the neutral is coming up and going into here. The actual, let me get this straight. The hot wire comes up and goes into the breaker up here, and then from there gets its power from here. So I got this straight. All of my 110 volt circuits are all tied to breakers at this point. Nothing is going to be separate. The light, I found out that it's not 120 volt, it's actually 12 volt. And I have no power source in here for 12 volt. So I'll most likely purchase a separate light and wire it up so that it's 24 volt or a 110 volt lamp. Most likely I'll do a 24 volt like LED or something, low current. I should have plenty of reserve power and this actual DIN rail power supply. And to the den rail power supplies there also wired up, so the load, neutral, and the chassis ground. Chassis ground is ran through here and tied into a connection point in the chassis here, and I've already pre-terminated them. The actual power supplies get their power from both of them are shared on a 3 amp. The total, this one was like 1.7 something or 1.8, and the other one was like 0.55 amps. So a little bit over 2 amps. So henceforth a 3 amp breaker to drive these two items. The actual motor driver for the spindle, that's all wired up, and it has not been, there's another there's a piggyback board that goes on here. I don't have it on here right now, but that goes on here, and then those items will get wired into that assembly there for turning it on, and the actual other wires go into the brushless motor, and we'll cover those later. Anyways, we will stop this video, and we will come back and we will start wiring up the DC voltages and having those set in position up to here. I've been putting the wire management covers back on, because when you start getting all these little loose wires, they start popping out and they're really lazy, and they, you know, I'm using stranded wire, not solid wire, so that when you take these off, they kind of flop out, and so it makes it kind of a hassle. So anytime I do sections, I just actually unsnap it and run the wire and then go from there. So anyways, that's this video episode. Please like and subscribe if you want to keep following up and get updates for this. We will be stopping this video, and we'll start on the DC wiring of this segment of the machine. So stay tuned.